to give an overview of whenever I visit presentations, I always like to get the big idea first. The big idea for Compose on IBM Cloud is that you can go sign up for IBM Cloud, use a Compose service, which is one of 9 open source databases, and begin using those databases within minutes after they're provisioned. All databases that are provisioned are production ready, so they come with backups, they come with high availability, they come with monitoring, 24/7 operations team, they come with a pay-as-you-go consumption model, so there is no you aren't paying for high usage and high utilization right out of the box. So it's cheap to get started, and it's efficient to get started, and it's a service that you can use today. So it's if you don't hear anything else in the rest of the webinar, those are the things that we want to take away from the webinar. Now I'll kind of step back and we'll kind of talk about how Compose as a service runs these 9 databases. We'll talk about some of the more in-depth functionality, some of the more in-depth benefits that you receive by using our databases. And then we'll talk about that with respect to data agility, the ability to prototype, the ability to launch quickly, the ability to test multiple types of databases with multiple types of data stores, so trying to understand what a prototyping model will look like. We'll also understand what the responsibility model looks like. Just because you use a database as a service doesn't mean that you don't have to know how to interact with the database. So there is some responsibility from the customer side, but we try to alleviate as much operation responsibility as possible with knowledgeable information as well. Then I'll hop into a demo, and I will talk about how Postgres works I'll show you how Postgres works on top of Bluemix, how MongoDB and Redis and Elasticsearch, Scylla, and RabbitMQ work. Those are all the databases I'll be covering today, and I'll talk a little bit more about them. So there's a lot of things on tap, but really it just comes back to running open source databases for customers in a production manner that they can use and get data agility from immediately. So a little bit about me. I was a high school teacher. So before, right out of undergrad, I was a high school teacher. That's been many years ago, but if there's anything I've learned, it's that we can, I can take questions and we can take things on the fly as we go, and that's the way I like to do webinars and do sessions, is by actually having some feedback and interaction. So I do have the chat open on my screen, so as you go and as questions come through, Michelle will handle some of those, and I'll also answer them as we go. So what is Compose? I chatted about it a second ago. It's an open source database service, so you can come to Bluemix, come to IBM Cloud. You can start up a Compose database and begin using it today. And how does that work? So we chose open source databases because even before we were part of the IBM ecosystem, we believed in open source databases. We've used open source databases in our previous jobs to deliver value, and we knew that there's a lot of value in the open source databases because they avoid the vendor lock-in, they're community-driven projects leading the industry. So it's as people within the ecosystem need a particular feature, that feature will be added back into the open source databases. It also cuts licensing fees and operationalize hardware costs. So as part of what we attempt to do is we attempt to run at near the cost of infrastructure. So we try to provide value to you at the running the services around the database, not merely by selling the database, but by running services around the database. So every component of the Compose catalog is purely open source. We do that to avoid vendor lock-in, embrace, and the most innovative technologies around open source. So we really embrace that open source, and we embrace that open source model, and we want our customers to be able to have the data agility that they need to have with these open source databases, whether they have operational expertise or not. So begin prototyping with that. The comprehensive catalog for simplified scoping. So selecting the appropriate database on the first attempt is rare. At the small end, so whenever you have smaller data sizes, Generally, you can choose any database, and it's going to perform okay. But as you scale, as your understanding of your product changes, as your understanding of your customer's product changes, as your understanding of constraints change, it's good to always be prototyping with your data, and prototyping with how you manage that data and how you understand that data, whether it's a warehouse model or whether it's a metrics model or whether it's an application data store, finding the right database for that use case. And as your use cases evolve over time, so do the database requirements. And that's why we choose to run some different databases, is because we understand that by plucking out a use case that isn't necessarily working in a main application database, you can actually reduce your overall cost of your infrastructure, of your database infrastructure, by choosing the right database for the job. So platform services need to be as flexible as your workloads. Additionally, you have workloads that are going to be come up. You're going to want to prototype something. You're going to want to see how something works. A customer of yours is asking you to perform new features. So you want to test these things, and that's where a database service like Compose and the ability to be able to just go out and start up a database that you've heard about, you haven't necessarily known about yet, but you want to begin prototyping on it and see how it works. You can do that from a Compose system. And then as part of Compose, you can carry that all the way into the production capability. So the great thing about Compose is we scale seamlessly as you grow upward. So a second ago, I said prototyping. I was kind of talking about the front end of data agility. And there's a lot of agility with the Compose service as you grow additionally, because we scale elastically without downtime. So as you use our service, as you add more data, as you increase your workloads on Compose, Compose will scale automatically to accept those new workloads. It will scale automatically to accept that new data, those new data sizes. So we grow seamlessly, and we have this auto scaling that works works for your data as you grow. So you have the agility on the small side, you have the agility on the large side to continue to scale, continue to grow. And then we also have enterprise-grade infrastructure. Additionally, so we have in a moment, I'll kind of talk about how you get multi-tenant, or you could get dedicated hosts. So you can participate in our multi-tenant infrastructure for workloads that can live within multi-tenant infrastructure, and then you can have dedicated clusters for those workloads that you want to that you must have on dedicated machines. So it's a way for you to move seamlessly between a private cluster and a non-private cluster for testing, so you can get the capability and agility and functionality that you need out of your data. And additionally, repeatable deployments for standard workflow. We have APIs. With our APIs, we can integrate into your continuous integration, continuous deployment systems. Those service consistencies deployed by best practice configuration. Whenever we launch a database, we launch it. We check the checklist that a DBA checklist that checks to go into production. So they're checking the backup button. We're checking the monitoring capabilities. We're checking the performance capabilities. We're checking the monitoring capabilities. We've got a 24/7 operations team that makes sure that your database is up and running. We deploy with high availability. We've got at-risk encryption as well, and it's fully managed infrastructure, so that underneath the database, the infrastructure that's running the database is additionally managed. And then there's scalability on top of that infrastructure so that you can grow and grow seamlessly. And it's repeatable and reliable, both in a cloud environment and the dedicated cluster environment that I talked about a moment ago. So this is kind of where Compose's benefits lie. And then what I'm going to talk about here is kind of where we sit in the two different worlds. So across the top, you'll see the databases that we run. You can run this on top of Compose Public. You can run this on top of Compose Enterprise as well. Compose Public is the multi-tenant. Compose Enterprise is the single tenant. We are cloud agnostic. we have integrated very tightly with Bluemix, but we are cloud agnostic, so we run across AWS, Google Cloud Platform additionally. So we can interact with each one of these different clouds well, and you get the same functionality whether you choose to run some of your workload in Bluemix, some of your workload in AWS, some of your workload in Google Cloud Platform. So we do work seamlessly and work with these additional clouds. And you get the similar capabilities between these different systems. So it goes back to the avoid vendor lock-in as well. We don't lock ourselves into a vendor. We do work very closely with Bluemix to leverage some of the capabilities we can't necessarily leverage in the other clouds, but we also don't lock ourselves into a particular cloud because we understand where customers work these days. So they choose particular clouds for different services as well. So stepping back a moment, kind of looking at the databases across the top, I will cover these a bit more in depth, some of them particularly. So we run MongoDB, we run Redis, we run Postgres, Rethink, Elasticsearch, ScyllaDB, which is a Cassandra stand-in. It's a columnar data store, RabbitMQ for messaging, MySQL, etcd, and Janus Graph. And Janus Graph is a graph database that's become popular with a lot of different workloads for the underlying capabilities. And we've determined as we've added this Janus Graph capability that underneath within every use case, it eventually becomes a graph problem. So having that has been a great add-on for when we can recommend customers use that graph database.
Hey, Chris, we do have one question. Where does Cloudant fit in?
Oh, great question. So Cloudant is a separate team within IBM. However, we do work closely with the Cloudant team. Cloudant is so I will take a step back for a moment. So Cloudant is a key value store, is a distributed key value store, and it really has the capabilities of Redis with a lot of the functionalities of MongoDB. So it's a different team within IBM. We work closely with them. We also, whenever people have come to us in the past to ask us about which database they should use, we've pushed people to Cloudant a lot of the times because they want a globally decentralized, eventually consistent data store that's a key value data store, and we say, great, run with Cloudant. So there's we don't like to necessarily favor one database for all workloads. So we've actually found Cloudant to be a great augment for some of the things that we just don't have within Compose. Great question. So the complete catalog of Compose open source services is available under both public and enterprise plans. Once you get Compose, once you sign up for Bluemix, you have access to all of these Compose databases. You can use any of them. You can begin using any of them. If you choose to go with an enterprise, Compose Enterprise, then additionally you can choose any of these databases within the Compose Enterprise within your own cluster on Compose Enterprise. So it's it gives you a lot of agility to move between that multi-tenant world and your own private cluster. So then you get the sizing, you get the cost, you actually get a lot of the different advantages, whether you choose public or enterprise. You can prototype on your multi-tenant, on our multi-tenant offering, and then you can take that as you move it into production. You can move those systems into your own private cluster. So we see a lot of different ways that people move with their different databases and the choices that they make. So, just because we call Compose Enterprise doesn't mean that our multi-tenant is not enterprise capable. We also have a lot of customers who run enterprise workloads on our multi-tenant offering. But within the multi-tenant offering, you can grow up to multiple terabytes of data within that enterprise offering. It's isolated, so it shares nothing. There's a more stringent SLA on the enterprise offering as well. And additionally, you can get the encrypted at rest capability. So you get additional enterprise functionality. So there are additional capabilities for the enterprise offering that you don't necessarily get multi-tenant, but a lot of our customers find success in the place they need to be, just through a bit of conversation, either through the support team, through our documentation, or even through sales personnel. So a lot of folks start at the multi-tenant and then graduate to the enterprise just for particular workloads. So how does this work? So I keep saying multi-tenant, I keep saying single tenant, I keep saying Compose Enterprise. So what we're looking at here at the bottom of this slide is an illustration of a composition of a Compose Enterprise offering. So someone who may be running Compose Enterprise as a single tenant, they may be taking up 256 megabytes of Redis. They may be using 55 gigs of Elasticsearch. They may have 4.5 terabytes of Mongo. They may have 20 MySQL or 20 gigabytes of MySQL. All of this within Compose Enterprise single tenant. Compose Enterprise is on the dedicated cluster for the customer, but it's all being partitioned and reused within that cluster by the way Compose works on the back end. So it's a single tenant to you, but you use it as your multi-tenant database offering. And what that allows you to do is to scale. So we set up the 3 nodes, and then within those 3 nodes, you can scale to use those 3 nodes. As you grow past those node sizes, we will add more capabilities and more functionality. So the system scales to meet your demand. So you get what's really nice about Compose Enterprise is you get a lot of the functionality that you need for enterprise, but you get a lot of the capabilities that you've learned to expect from the cloud, such as auto scaling and right sizing of your resources. So feature comparison to kind of set up the two, you do get the same infrastructure. You do get slightly larger size capabilities on enterprise, and that's just because we removed some of the multi-tenant capability. Tenancy, you get virtualized multi-tenant versus dedicated multi-tenant. With SLAs, public is an optional SLA. You do get an SLA on Compose Enterprise. Management's the same, elasticity is the same, high availability is the same, backups are the same. So the things that we consider production grade, management, elasticity, HA, backups, monitoring, and operations team, all those are also included in both offerings. So why choose enterprise? You get data isolation and single tenancy. You get a little bit more flexibility in the cloud regions and deployments. You get to check a little bit more of the compliance because of the compliance checkboxes, because of the dedicated clusters. Performance, you are running on bare metal hardware. There's not much issues with isolation as far as performance in our multi-tenant world, but for those that are looking to eke the most amount out of their performance to reach the maximum capacity for their databases, we do recommend Compose Enterprise because of just improved performance isolation. For data sizes, you can grow your clusters much larger. You do get encryption at rest and data sovereignty. So if you run in a particular data center, your enterprise data will not be shared or replicated outside of the environment for backups or anything like that. So everything stays within the data center that you have specified with particular constraints. So there is a bit more capabilities with Compose Enterprise and a bit more of the compliance checkboxes and needs based on based on your enterprise needs with Compose Enterprise. So that was what we're going to take a bit of a change of the question that we're answering now. So previously we were talking about, we started off with what are the features that Compose offers, how does it bring those features to you, and then we started talking about how does Compose run, and we talked about with Compose Public and Compose Enterprise. We talked about what does Compose run with the different databases. We talked about a bit of the features. So let's talk about more of those features. It's what is managed. Managed is a word that gets thrown around a lot within particular cloud ecosystems, and it's managed has lost a lot of its I guess power just because it does get used so much. So we like to tell you explicitly what is managed. So we manage infrastructure, orchestration, high availability, backups, restores, monitoring, and security. On infrastructure, Compose and IBM serve as the purchase broker between the customer and the infrastructure. So you purchase directly from Compose, you purchase directly from IBM, and then what you get is we handle the hardware. We handle the underlying provisioning of that hardware, standing up that hardware, getting it provisioned and ready to accept databases. We're also handle the right sizing of that hardware to make sure it handles the type of performance that you need. And this happens on both the public and the enterprise clusters. So we provision the hardware, expand the hardware, replace hardware at end of life, repair and replace failed hardware, DNS configurations, RAID configurations, performance to RAM, CPU and disk scaled proportionally, best practices. We handle all that. And in a cloud world, oftentimes we forget that there are servers underneath that, but even talking about the servers that you get, the services that you receive through Compose is important to start with the value. So the value is you get incredibly performant hardware that is managed. And then orchestration. So we use a technique called containerization for running multi-tenant. So what we get from containerization is we can create patterns of provisioning that creates this orchestration. So we use this containerization for the provisioning of the database, for scaling of the database, for version upgrades and patching. It allows us to do some improved host monitoring and host provisioning. So containerization is the tactic that we use to fulfill our orchestration strategy. And then we also provide high availability. A lot of times when you talk about databases, talking about high availability happens at the data replication at the database level. We consider high availability built from the ground up. So we provision into multiple availability zones. We provision into multiple racks. We keep everything isolated from each other. All of our data is replicated at least 2 ways for all databases, depending on topology. So at least 2 ways, though. So you have data on two different servers, one as a leader and one typically as a hot standby or a follower. And then we have high availability for auto failover. So there's a lot of checkboxes that we check on the high availability to be able to achieve the 99.98 SLA for enterprise. Backups and restores. We pride ourselves on the ability for customers to be able to restore quickly. So a customer being able to restore within moments from a backup. So they're enabled by default. There is no configuration you have to run. We run it as a best practice. You get 7 daily snapshots, 4 weekly roll-up snapshots, and 3 monthly snapshots stored up for free on either S3 or Cloud Object Store, depending on where you choose to run your database. And then restores from snapshots into freshly provisioned instances initiated. So you can actually perform these with API requests coming up shortly. Currently within Bluemix, they're via support ticket request. They will be automated and will have API requests shortly. Within compose.com, you can, and the Amazon services, you can provision those restores without having to talk to a support, without having a support interaction. That support interaction will be removed shortly within Q4 of this year for the Bluemix integration. So monitoring is interesting because we do encourage our customers to monitor their databases from an application perspective, but we consider it our responsibility to monitor the database for performance, monitor the database for resource usage. We do capture all the logs and provide the logs back to the customers. And then we also have a 24/7 ops team as part of that monitoring. So our 24/7 operations team, if any of these monitoring alerts or configurations find that a database has fallen out of bounds, either through over resource utilization, or a high availability system has failed and fallen over to the primary, our 24/7 operations team will actually will wake up or either return, or if they don't have to wake up, return health to the cluster, return health to the database without the customer knowing. If the customer does log into their screen, they will see the monitoring status there. But if you don't log in, then it will just be transparent in the background that we've rescued a system that may not have been able to be rescued by our automated systems. So we do have the automated systems in place. Those automated systems take care of most issues. If those automated systems don't, then we do have an operations team that will handle the rest of those issues. Security, Compose manages enterprise encryption keys for in-flight data and data at rest. You also do get SSL certificates. So we handle the stack. And then what is not managed? So it's always important to talk about what's not managed from a database service perspective, because we like for customers to know where their responsibility ends and where Compose's starts, and where Compose's responsibility ends and the customer's responsibility starts. So, and that happens at the interaction with the database. So Compose is not responsible for application design. We don't do code refactoring. We don't do application performance monitoring or application debugging. We don't build queries or indices. We don't connect the application code to the database. We don't understand the client application code. And then this next one is the one where we try to provide assistance, but it's also up to the customer to understand how databases work with query and overall performance, and then managing costs. So performance and cost go hand in hand a lot of the times. Query, data size, performance, cost, all those things are different sides of the same triangle. So it's, as I said earlier, customers can prototype on the small side, and they can get a lot of the data agility on the small side. As a customer grows their data size, it is important for the customer to become, to understand how their database, how the underlying database works, but not necessarily understand how to operate it. But they can, but as long as they understand the query philosophies and the tuning practices and the query best practices and the indices methods, then they can continue to grow on top of Compose and have success. But there is that element that the customer does need to understand the query and the overall performance. So Compose gives you a jump start on the operational side by making a database production ready, and then you can consider that instead of having to understand the operations, the customer can dive into the interaction with the database to really extract their value and get the most amount of value. So let's do a bit of a demo. Before we do the demo, Michelle, have there been any additional questions?
No other questions. So folks, if you do have a question and want to ask directly, raise your hand and I will unmute your line. So we'll just take a minute for folks to ask questions.
Excellent.
Okay, I think you're doing a great job, Chris, because there's no questions.
Excellent. And again, if you have any, I'm more than willing to take them on the fly. There's no need to wait till later. So excellent. So the next step that we're going to do is a demo. The databases that we're going to talk about. So we've talked about Postgres already. So if you're within IBM Cloud, the IBM Cloud login, if you're in the portal there, you can go to catalog here. Let's see. So click catalog. And then from catalog, if you type in Compose at the top, we'll get a list of all the Compose functionality. Michelle, is my screen large enough to be seen well, or do I need to increase the size?
I would increase it a little bit.
Okay, 1 second, I'll do that. Is that better?
It actually looks smaller to me.
Okay, that's it. Let me try one more. One more tactic.
There, that looks awesome.
Excellent. So here we've got, we're within the IBM catalog. We can see all the capabilities, all the services available within, IBM Cloud. And then if you type in compose within that catalog, you will see all the IBM services that we talked about a moment ago. So you do see enterprise, which is you go here to purchase your cluster, and then after purchasing the cluster, you can go in and provision to that cluster. If you don't have a cluster, you can just continue with the multi-tenant offering. So we're going to take a look at the Postgres offering first. Okay, I've clicked on that. So we've got a bit of a description here. We can say Winslett webinar demo. We can apply some credentials here. So select region to deployment in. To deploy in, we can go US South. And then my organization and my space, we can leave unbound. And now what we'll see here are the pricing. There is a bit of, there is a tiered graduation, which I will talk about a little bit later about how we do pricing. So I'm going to choose the standard offering, and then I will click create. And now we will see this provision. It takes a second. It's still minutes. Oh. Okay, 1 second. While that one is spinning up, we will pop over to compose, and we'll do check out MongoDB. And then while that one is spinning up, we'll take a look at Redis. And these are three of our largest, most often used databases. Postgres is a great application data store. It's SQL, so it is directly compatible with a lot of SQL knowledge that people already have. There is a little bit of application tuning if you're coming from a different SQL database, but you'll find it quite familiar. Redis is a key value store that works great as sessions, also for caching and that type of stuff. And then MongoDB is a document data store, and that document data store can be queried and much like SQL, but with slightly different syntax. And MongoDB works great. It's highly flexible on the small data size. As you grow it, you'll want to convert to more in a key value kind of store for sharding, but it's extremely capable on either end. So Redis, let's see, Redis. Winslett Redis for webinar. Let's go ahead and create that. And then let's do Winslett MongoDB for webinar. Pricing plans, go ahead and create. Oh, it did create it. It just responded with a, let's see. Okay, so here is the Postgres database that I created a moment ago. Within this Postgres database, we can go to view more, say connections. Okay, so we can connect it to an application. If we're running an application, we can connect this Postgres to an application. If we do choose to add some credentials, we can add some credentials here. If we choose to view the service credentials, we can view them there, and then we can connect directly to the database. So what we aren't seeing here is some of the additional capabilities. It looks like it's just taking a moment to load, but let's give it some time, and then we'll pop back to it after the rest of the presentation. 1 second while I hop back over to the presentation. Okay, you should see the demo screen now. Correct, Michelle?
Yes.
Excellent. So you kind of saw, oh, go ahead.
Now I see your slides, I believe.
Yes, I'll pop back over to the slides to let the databases spin up. I just noticed that we were running a bit short on time, so I wanted to kind of hop through the different databases and use cases that those databases support. So we've got to kind of hop back over from the demo. We're going to let those databases finish creating some of the compose infrastructure. So it's setting up the backup, setting up the cluster, setting up the replication HA. And so let's talk about why we run these different databases. I'm going to kind of step through some of these most common databases that I picked out a moment ago. So with MongoDB, it's a document data store. It's not a document data store like documents, like Word documents. It's a document data store like JSON. So if you're familiar with JavaScript, then you're familiar with JSON formats. They're just a hash structure within a hash, or really just a hash structure within JavaScript that can be moved back and forth. And MongoDB really latched onto this JSON format where you can apply any kind of document to the database. You don't have to predefine the structure. You just insert the document, and then by inserting the document, the database just accepts that document. It doesn't optimize querying on that document until you build the indexes on it, but it does accept that document, and it does make it queryable, but it's just not an optimized query. So document databases conceptualize the database as storage for multiple documents. Within a database, every document can have a unique schema. So you can, every document can be completely different within a database. There is no schema or no schema constraints within MongoDB. So every data can be incredibly complex with nested JSON documents, with nested representation, and none of that requires pre-design on the front end. You just kind of go with the flow with MongoDB. And then users query into that document structure and retrieve portions or either update portions of it. So what's really nice about MongoDB is it is capable of modifying that document on the fly. Other Postgres does support some JSON capabilities like MongoDB, but but MongoDB really does it in a better native way than Postgres does. So recommended workloads for document databases, sharding and partitioning of data across multiple nodes and data centers whenever you need high availability and scalability. With JSON documents, you do get a lot of you do get eventual consistency in a MongoDB cluster. So with that eventual consistency, you can actually do some right-tuned consistency, but the eventual consistency, the way the documents are structured means that you can, you do get more high availability, more flexibility. You get better partitioning, but you don't necessarily get the consistency that you get with a SQL database. But you do have schema flexibility as well, and you do have fast write times. So where the question about Cloudant earlier, so Cloudant excels. Where I would choose Cloudant over MongoDB, if I needed a globally distributed database, I would choose Cloudant. If I was looking for a highly available database within one data center that was looking for unknown querying in the future, I would look more towards MongoDB because it does have a few more of those capabilities. So Elasticsearch is one of the other databases that we're looking at. So Elasticsearch is available through Compose on Bluemix. It was one of the other ones offered in the catalog. So Elasticsearch is a document data store. However, it's considered a specialized application solution, not necessarily a canonical database. We do recommend that customers keep their, if you're using Elasticsearch, we do recommend customers have another database that has the canonical data in it. So with Elasticsearch, we see it paired a lot of the times with MongoDB, Rethink, Postgres. We see Elasticsearch used with just if you need more advanced search capabilities. It also does a really good job of extracting complex search use cases that can be abusive to the main application database. By extracting that from the main application database and putting it in a Elasticsearch cluster, you do get better performance and better price to performance capabilities. And then, so Redis is one of the ones that we also chose a moment ago. So we've talked about MongoDB as a document store, Elasticsearch as a search-specific database. Redis is a key value store, and it falls under the category of NoSQL, but it's really also a specialized application solution. It's not necessarily something that you can query like you can a SQL database. So where we use Redis internally at Compose is as a session cache. So keep the session key, session information within Redis. Keep the anytime we want to cache a page or cache some information for quick retrieval later that we don't necessarily want to go back to the application store, then we'll store it in Redis. So Redis is really just a way that a lot of people use it to extract more performance out of their underlying application database. So Redis, it's a bit, it's actually quite simple. So it's just sorted by unique keys. So you'll have a key, and then that key will have a value. It's about that simple. You can do different types of values. So you can use integers, you can use strings, you can use arrays, you can use sets, you can use sorted sets. There's a lot of different ways to structure your value that gets returned from a key, but it's still quite simple. Where we talked about key value a moment ago, Cloud is considered a globally distributed key value database. So performance and rapid scalability, constant stream of small reads and writes, all these kind of fit into the key value store database. Memcache is one, and then Redis, and then additionally Cloud. So Postgres is a traditional SQL database. The ones that we've mentioned previously have all fit under the category of NoSQL. So Elasticsearch is NoSQL, Redis is NoSQL, MongoDB is NoSQL. Postgres is fully SQL. So it's a traditional, you design your tables, you design your schema, you have very rigid schema, you insert your data using SQL statements, and you can query it using SQL statements. So it fits a lot. SQL fits a lot of different use cases. SQL is incredibly powerful, and then we see people use these other databases I've been talking about to augment their SQL capabilities. Then we've got RabbitMQ. So RabbitMQ is a message bus. It's a message broker. So it's open source with Apache. We do have this says competitor with IBM Message Hub, but it's not really a competitor. There are different use cases where I'd use Rabbit versus when I'd use IBM Message Hub built with Apache Kafka. So this is where we get back to that prototyping as well. Compose internally uses RabbitMQ for a lot of message management, for a lot of broker stores, and for a lot of broker message distribution. So it's a common usage pattern, and it's one of the first messaging systems. Message queues are one of the first things that are typically extracted out of a SQL database or out of the main application database for things that are growing. They really provide a lot of leverage for growing much more cheaply. ScyllaDB. So we talked about MongoDB as a document data store, Elasticsearch as a search-based data store, Redis is a key value store, We talked about Postgres as traditional SQL, RabbitMQ as a message bus, and now ScyllaDB. So Cassandra, Scylla, columnar data stores have been a hot topic for databases that are growing at great scale, at great size, that also want to retain some better querying capability. But also with this comes increased complexity. So you have much more complex. Once you get into Scylla, you're getting into a much more complex set of questions that you have to answer, such as how you want to design your schemas specifically for Scylla to perform well. How do you want to? What use cases do you want to bring in there? So you just have a set of columns within a columnar data store. Queries are very similar to SQL, but slightly different. There's no schema enforcement, but columns can be sparse. You also have to design your indexes better to have just enough cardinality. So traditionally with SQL, you want to have a high cardinality database. With something like Scylla, if you have too high of cardinality, then it doesn't really. It becomes expensive to create an index and keep an index up to date. So you want to have just enough cardinality. There's a lot of different constraints there, and that's why we kind of get back to prototyping as well. If you want to explore a columnar database, or you want to explore Scylla or explore a drop-in replacement for Cassandra, come spin up ScyllaDB on top of Bluemix and with Compose and test it out. See what works, see what doesn't, see how some of your assumptions and some of your learning models can change based on being able to explore the database. So recommended workloads for column family databases. Let's talk about what they aren't good for right off the bat. They're not good for warehousing. Relational database management systems are far better for warehousing and for querying on those warehouses and for just that type of data store. Columnar data stores are better tuned to be specific application use cases. So we want to take this use case that we need to scale, and we want to make it and we want to build it much cheaper than we can on traditional databases. So they're very good in high write throughput and lower read throughput. So it's important to have that proper type of use case. So we kind of walked through the different databases there. We walked through MongoDB, Elasticsearch, Redis, Postgres, RabbitMQ, and ScyllaDB. And what we're going to talk about next is the pricing and the way the pricing graph works that I showed you previously inside of Bluemix. So it's and this is where we really like to leverage our pricing for prototyping. So as you can see, there's a couple of databases I left off here. I figured I wouldn't necessarily have time, but they're there for exploration, and they're easy to use, and we have plenty of documentation for beginning exploring on that. But for MongoDB, your first unit, you can start for $18 per month. So you can do that with MongoDB. Postgres is $12, Redis is $13, Elasticsearch is $36. Rethink, another NoSQL database similar to MongoDB, is $18 per month. So we have very reasonable starting points. And if you notice, we also scale based on the storage. So your second unit, so if you have MongoDB and you have 1 gig, you start at $18. If you have TAD, your second gig will be at another $18, so you'll be at $36. Now, the good news about this is that you can, with this pricing structure, with the way that this works, is you can start cheaply, you can prototype, you get billed by the hour. So you only get billed by the number of hours that you use prorated to the month. So if you only use it for today, you only get charged for today. So spin it up, create it, prototype it, test it out. It is production ready for when you need to go in production. But if you start doing the math on this, you're thinking, oh, this gets expensive quickly. It's like, well, actually it doesn't. and it doesn't get expensive quickly because we have these incentive tiers that we do pricing with. So as you graduate, as your MongoDB gets larger and larger, as your database becomes larger and larger, as you use more underlying storage, you do get significant cost decreases. So as you jump into the 10 gigabytes to 24 gigabytes, then you're only charged $16.20 per gig. So there's a reduced per unit pricing as you grow. And what we're trying to do is we're trying to, as you grow, we try to share that that expected plan growth with you. So we try to incentivize you to grow. We want to make it something that is good and something that really supports your business as you grow. And then that is the end of the presentation.